Hola, 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 probando. No. Sí, sí, sí. Ahora sí. Hola. Hola, 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 hola. Perfecto. Welcome, everyone. It's good to see you again. How have you been? Buenos días. Welcome, everyone. Today, we're going to prepare a little review for the entire topics of the lessons. Then we are starting from the last Friday until yesterday, if God wills. So we're going to start with the synthetic division, series of the function, operation with the function, combinations, and also the inverse of the function. Okay. If you have some doubts or questions, don't hesitate to let me know. Right. I'm going to change the camera, pin my video, and that's going to start with the first part of the problems. Okay, so once again, this is a review for synthetic division, series of function, operations, combinations, and inverse of the function. All right, in the first part, obviously the problem says find the quotient remainder of the polynomial, and we got two polynomials. Letter A got cx4 power plus 10x third power plus 5x squared plus x plus 1 divided by x plus 2 thirds. And the second part, we got gdx equals x cubed minus 27 over x minus 3. So we must try to looking for what will be the quotient remainder by means of the synthetic division. Remember, we're going to apply synthetic division because the denominator has the form x plus c or x minus c. Okay, so first of all, what will be the first step? Remember, in the synthetic division, always the first step will be determined by looking for what will be the value from the symptom. For that reason, we're going to take the denominator, x plus 2 thirds, that will be equal to 0. And so for x, and the result will be negative 2 thirds, right? So in this case, this is going to be the number who's supposed to divide this synthetic division. Okay, continue then. Let's going to check if the numerator is in canonical order. X4, X3, X2 is 1 and 1. So that means there's no problem. So we have in this part in the canonical order, I'm going to copy the numbers. 6, 10, 5, 1, and 1. And remember, we have the horizontal line, the horizontal line. We got the vertical line, sorry, horizontal line, and horizontal line. And over here, we must divide it by negative 2 thirds. And let's going to proceed to applying the synthetic division. So the first thing that we must do, we're going to copy downward the red line, the number 6. Okay, and 6 multiplied by negative 2 thirds. 6 times negative 2 is negative 12. Divided by 3 will be negative 4. Okay, so 10 minus 4 will be also positive 6. Again, 6 times 2, negative 2 is negative 12. Divided by 3, also negative 4. Okay, 5 minus 4 will be 1. 1 times negative 2 thirds, that will be negative 2 thirds. And 1 plus 2 thirds, that will be 1 third. 1 third. And 1 third times negative 2 thirds will be negative 2 over 9. And 2 over 1 minus 2 over 9, the answer will be 7 over 9. Remember, always in the synthetic division, always, 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 the last number will be the remainder. So if you want to establish who's going to be the quotient, quotient, I mean the body's QDX. All right, remember, we're starting from x4 power. Now we're going to use these numbers, subtracting 1 degree in the power. For that reason, we got 6x squared, s cubed, sorry, 6x squared plus 6x, plus x plus 1/3. This is going to be the quotient. And the remainder, r dx, will be equals positive 7/9. And we got at least the solution set, at least for the first problem in the letter A. Okay, same happened with the letter B. We got x cubed minus 27 over x minus 3. What will be the first step? Again, we want to take the denominator and equal by 0 to determine what will be the value from the vertical asymptote. And as soon as you can see, this vertical asymptote will be given by x equals 3. Okay, now, again, let's going to proceed to divide this long division. But remember, in this long division, we must be canonical order. In this case, we're starting from x cubed. That's supposed to, after x cubed, we have a number 1 imaginary number. That's supposed to follow x squared, x, and the number. And because there is no x squared and x, we're going to complete the canonical order adding zeros. I mean 0x squared, 0x minus 27. In this situation, can be divided by, obviously, by the vertical asymptote. And remember, the vertical asymptote will be the number 3. And once again, I'm going to repeat the process. At the moment I'm going to repeat the process, the number 1 will be located downward this red line. And let's going to multiply. 1 times 3 will be 3. 0 plus 3 will be 3. 3 times 3 will be 9. 0 plus 9 will be 9. And 9 times 3 will be 27. And 27 minus 27. All right. This case, the remainder will be equal to 0. Remember, without exception, in the synthetic division, the last number always will be the remainder. Now let's going to identify QDX and RDX. QDX, the quotient, we're going to subtract 1 degree on this case because at the beginning we started from x cubed. Now we're going to start with x squared. 1x squared plus 3x plus 9 and RDX, that will be equal to 0. And we're concluding the first part of the review. Find the quotient and remainder of the two functions. F the x equals 6x4 plus 10x cubed plus 5x squared plus x plus 1 over x plus 2/3. And letter B, x cubed minus 27 over x minus 3. Okay? Now, in the second part, the lesson we learned in the last Monday, we have to find out the series of the function and write the answer in factor form of the polynomial. What does that mean, this polynomial? This polynomial, we got 2x fifth power plus 5x4 power minus 8x cubed minus 14x squared plus 6x plus 9. Okay? Remember, x to the fifth power, that means we're going to have 5 solution set for the letter x. So we have to find out five answers to obtain the answer. And remember, to determine which number we're supposed to divide this long division, we must establish what are the values from the p factors and q factors. The p factors will be the multiples of this last number. I mean, the multiples of 9 will be positive -1, positive -3, and obviously positive negative 9, because all of them are the multiples of 9. And the Q factors, that will be the division between the multiples of the first number. What are the multiples number 2? Obviously will be positive negative 1 and positive negative 2. So because we have P and Q factors, we can conclude the possibility to divide all of this stuff will be divided, all the three numbers divided by these two ones. For example, when divided by 1, we have the same values, 1, 3, 9. But at the moment we need to divide it by 2, it could be positive negative 1 half, positive negative 3 half, and positive negative 9 half. This is going to be the possibility, the possibility, or the quantity of numbers that we're supposed to choose at the moment they're going to provide the synthetic division. And what number will be the zero of the function in this case? Well, simple. The number, the chosen one, that's supposed to give us 0 in the synthetic division, the remainder. All right. We're supposed to choose one number between this beautiful list: 1, 2, 3, 4, 5, 6. 6 times 2, 12. 12 combination, because we have positive and negative numbers. How to do that? Well, it's a random number, random selection. I'm going to start with the positive one. Let's see what happened. Okay, let's going to copy again. And by the way, as soon as you can see, this polynomial is complete in canonical order, because we started from 5, 4, 3, 2, 1, disappear. So we can start with the synthetic division over here. 2, 5, negative 8, negative 14, positive 6, and positive 9. Divided by what? Well, just as I said, let's going to try with the positive 1. Let's see what happened in that case. Okay, here, and let's apply the synthetic division. All right, so positive 1. Let's see what happened. Okay, remember the first number, copy downward with this red line, and we got 2 times 1 will be 2. 5 plus 2 will be 7. 7 times 1 will be 7. Negative 8 plus 7 will be negative 1. Negative 1 times 1 will be negative 1. And we got negative 15, right? Negative 15 times 1, negative 15. 6 minus 15, we got negative 9. And negative 9 times 1, we got negative 9. And oh, so let's see, I'm choosing the right answer of the beginning, but this is merely coincidence. There's no mathematical technique or super strategy to determine, I always choose that number and always give us 0. This is a try and error. I choose positive 1 and, well, in simple merely words, or the random situations, and in Spanish were said, I choose the number 1 by the ancestral technique what we call chiripa, C is and C. Now, because the remainder is 0, that means the number 1 belongs to zeros of the function. Now I'm going to write a new PDX. No quotient and remainder, because we're looking for zeros of the function. We're starting from 2 to what? 2x4 plus 7x cubed minus x squared minus 15x minus 9. All right. And because the last number still have the number 9 and the first number still the number 2, the P and Q factors will be the same. So we're going to maintain the list of these numbers, because the last one is 9 and the first one is the number 2. And because we have a canonical order, let's see. Again, I'm going to copy the numbers: 2, 7, negative 1, negative 15, and negative 9. Okay. And because of that, let's going to choose another random number. Cualquier número aleatorio que usted quiera. Let's see what happens. All right. Let's going to check for this case, I'm going to check or going to choose one fraction. I'm going to choose 3.5. I don't know what you think about it, but this is a try and error. I'm going to choose 3.5 because it's the number located over here. And let's see what happens if I'm doing well or wrong. So remember, I'm going to copy downward in the red line, the number 2. And why I'm choosing this fraction? Because 3.5 is the denominator is 2. With this number 2, we can cancel that one. That's why. All right. 2 times 3.5, that will be 3. Okay, 3. 7 times 3 is 7 plus 3 will be 10. All right. 10 times 3.5, 10 divided by 2 will be 5. 5 times 3 will be 15. Okay, 15. Minus 1 will be 14. 14 times 3.5. Okay, 14 divided by 2 will be 7. 7 times 3 will be 21. Minus 15 will be positive 6, right? 6 divided by 2 will be 3 times 3. Oh, positive 9. If you see, parece que ando con suerte hoy. 9, negative 9 minus 9. Sorry, 9, negative 9 plus 9, that will be 0. What does that mean? That means the value 3.5 is also a function. So we're doing well. We're going to copy once again the new polynomial. Sorry. PDX equals 2x, but what will be the power? Here we're starting from 4. Now we're going to start with the number 3. 2x cubed plus 10x squared plus 14x plus 6. Okay, we had the new polynomial, but because this time the first number is number 2, but the last number is number 6, the P and Q factors will change because the new P factors, we're talking about the multiples of the number 6, and that will be positive negative 1, positive negative 2, positive negative 3, and positive negative 6 over Q factors that will be equal to positive negative 1 and positive negative 2. All right. In conclusion, these 4 numbers divided by 1 will be the same 4 numbers. 1, 2, 3, and 6. How about divided by 1? 1 divided by 2, okay, positive negative 1/2. 2 divided by 2, 1. There's no make sense because we have the number 1. 3 divided by 2, okay, 3.5. And the last one, 6 divided by 2 will be 3. Number 6 because we have the number 3. So the P and Q factors, the new ones, will be between this list of the numbers. 1, 2, 3, 6, 1/2, and 3.5. We must choose another number. Well, let's see, either the beginning, we're starting from number. Well, let's see what happened. I choose the negative 1. Let's see what happened. Again, I'm going to copy the polynomial, 2, 10, 14, and 6. Okay. Let's see what happened. We have the synthetic division again. And we said negative 1, right? So we got negative 1 over here. And remember, we're going to copy the number 2 downward to the red line. And let's see. 2 times negative 1, we have negative 2. 10 minus 2 will be 8. 8 times negative 1 will be negative 8. 14 minus 8 will be positive 6. And 6 times negative 1, okay, we got negative 6. And 6 minus 6, what does that mean? That means we're going to have 0. All right. Now, we're going to, again, copy the polynomial. And we got p dx equals 2x squared plus 8x plus 6. Oh, okay. And because we have a quadratic equation, you have the option to continue providing the synthetic division. Or at the moment we have a quadratic equation, remember we got 3 techniques of solving this stuff. We can use the trial and error technique. We can use the completing square, or if you wish, the quadratic formula. I'm going to solve this quadratic equation by means of the trial and error technique. And we got 2x squared plus 8x plus 6 equals 0. And actually, we can take the common factor, number 2, and we can factorize this expression like a x squared, 4x plus 3 equals 0. Because this number 2 is multiplying with passes to divide, 0 divided by 2 will be 0. And we got x squared plus 4x plus 3 equals 0. And this time the equation will be easier for us because we have x plus and x plus. A couple of numbers. Well, their product gave us 3 and the addition gave us 4. Obviously will be 3 and 1. And x will be equal negative 3 and x equals negative 1. All right. And we are finally found the zeros of the function. Okay. Remember, we're supposed to have 5 solutions. Let's see if that's true. 1, 2, 3, 4, and 5. What will be the difference? The difference, negative 1 repeat twice. Then we're going to say multiplicity of 2 because it repeat 2 times. If the negative 1 repeat 3 times, multiplicity of 3 and so on. So this is going to be the list. Zeros are negative 1 and negative 3, sorry. Negative 3, negative 1 twice, multiplicity twice, 1 and 3.5. Okay, 1, 2, 3, 4, and 5. We have the 5 zeros of the function. Negative 3, negative 1, multiplicity twice, 1 and 3.5. And if you really want to write this polynomial in factor form, it's simple. The original PDX will be written the following way. Well, we had the first factorization, x plus 3. We got over here x plus 1. And because this solution repeat twice, elevated the second power. We got over here positive 1. That means, okay, that solution was x minus 1. Okay. And finally, 3.5. That what does that mean? Is 2x minus 3. Because if you have 2x minus 3 equals 0, all right, if you solve for x, the answer will be 3.5. And this is, my dear students, the answer. This is the zeros of the function, negative 3, negative 1, multiplicity twice, or multiplicity of 2, is the same, 1 and 3.5. And the factor 4 will be this beautiful polynomial. And this is going to be at least the solution set for the first lesson, synthetic division and zeros of the function. Questions?
A high question, mister.
Uh-huh.
In the number two, right, we need to do all that process. And it is always answer that needs to be given.
Okay, say it again, the question. In the part number 2, the zeros of the function. Uh-huh.
Yes, we need to exactly do get 5 answers, right?
Yeah, remember in the part of the series of the function, we have to looking for which number or what number we're supposed to divide the polynomial. In the main idea of the objective, we'll be trying to looking for a chosen number whose the remainder that will be 0. All right, this is the purpose. And always, we're going to determine the P and Q factors or the multiples. The P multiples of factors always will be, without exception, the last number. Always, the last one. And what are the multiples of 9? 1, 3, and 9. Okay. And the Q factors will be always the first number, whose leader, the leader coefficient, in this case, the number 2. And divide the 3 numbers divided by 1 will be the same. These 3 numbers divided by 2, we have the list. And what is the tedious part on that situation? The tedious part of this situation, you have to choose, or you must try one number by one number by number until you got the answer like a 0. For example, you can, in this case, and choose the number 1, and we try at the first try because that was a low key, just to tell you the truth. But you can choose 3, 9, and you're going to see this is not a 0 because the remainder gave us a different number than 0. But if you got the first one and the answer is 0, this is going to be a 0 of the function. And every time that you're success in the polynomial, you're going to write the numbers of this answer, but remember decreasing 1 degree of the letter X. Got it?
Yeah.
Okay. Another question, guys? No? All right, I'm going to send you a picture in the WhatsApp group. Let me hold on a second. Pre-algebra, you got it. I'm going to send a picture. Okay, here we go. You got the picture in the WhatsApp group. All right, let's continue. Now, what will be the next part of this review? Well, you know how to apply that synthetic division. And of course, you learn how to find out what will be the values of the zeros of the function and how to write the answer in factor form, right? Now, let's going to try with the operation of functions, combination, and inverse, all right? Okay, in the part number 3 says, given the following functions. F of the x equals 3 over x minus 2. And g dx equals x plus 5. Find letter A, f plus g, B, f minus g, C, f times g, and D, f over g. All right, remember, just like in arithmetic, the 4 basic operations in arithmetic will be addition, subtraction, product, and division, right? The quotient. Same happens with the functions. What the theorem, remember the theorem says, when you have the function denominator, f the x, g the x, or not necessarily f and g. You can choose like a rdx, bdx, or mdx, adx, and something like that. Actually, the theorem says if in arithmetic you can add, subtract, multiply, and divide the numbers. Okay, so in the functions happens with the same situation. That's why these 2 functions are given. So in the first part says, okay, let's find out what will be the addition. I mean, f plus g. Well, f plus g, we're going to add the two functions. We got the first one is 3 over x minus 2. We're going to add x plus 5, okay? Remember, we have the least common denominator. This is going to be the number 1. And remember, for adding fractions with different denominator, first of all, the least common denominator. Or simply worse, multiplying the denominators. I mean, x minus 2 times 1 will be x minus 2, okay? Now the next step, we're going to apply cross multiplication starting from to the left side into that denominator, numerator and denominator. 3 times 1 will be 3, okay? Plus the product between x plus 5 times x minus 2. Please avoid the temptation to cancel x minus 2. You cannot do that because we have addition. Instead to have positive, negative, we have a product 3 times x plus 5, x minus 2 over x minus 2, go right ahead. You can cancel in multiplication or division, but you cannot cancel terms every time that we have addition or subtraction, okay? So let's going to simplify this expression applying distributive property. We got 3 plus x times x is x squared minus 2x plus 5x minus 10 over x minus 2. And finally, the answer will be in canonical order, x squared, 5 minus 2, positive 3x, okay? And 3 minus 10 will be negative 7. And this expression over x minus 2. And we got the first solution, the first operation, addition of two functions, x, f plus g, okay? How about in the second one, f minus g, okay? In f minus g will be the same situation, but instead to adding, we must to subtract. I mean, 3 over x minus 2, subtracting x plus 5, and we got the number 1 imaginary number. Okay, same happened over here. Actually, the result will be the same, but what will be the difference? Instead to have a positive number over here, we're going to have a negative expression. I mean, 3 minus x plus 5, x minus 2 over x minus 2. All right, same situation. What is the difference? Instead to copy positive, this time it will be negative. The distributive property will be the same, but what will be the difference this time? This time, at the moment, we're going to apply the distributive property. Because I have a negative sign, I have to overprotect this polynomial by the negative sign, because that negative sign will change the final operation. So as soon as you can see, the operation will be x squared plus 3x minus 10 is the result to multiply x plus 5, x minus 2, okay, over x minus 2. It's what's going to happen. What's happened is this negative sign will change the symbol of the entire numbers. We have 3 minus x squared minus 3x positive 10 over x minus 2. And we got the like terms. 10 plus 3 will be 13. 13 minus 3x minus x squared or over x minus 2. Or if you want to write the answer like x squared, the negative x squared, negative 3x, positive 13 over x minus 2, don't worry, the answer will be the same. Understood? Understood, guys? Yes or not? Confirm.
Yeah.
All right.
Yes.
And just for finish, because we have almost out of time, we have the product between f times g. In this case, we're going to multiply the fractions. I mean, we got the first fraction is 3 over x minus 2 multiplied by x plus 5. Remember, multiplying fraction, we have a number one imaginary number. We must multiply into straight line. I mean, 3 times x will be 3x plus 3 times 5 will be 15 over x minus 2 times 1 will be x minus 2. And that's it. Well, the pending work will be f over g. We can make it f over g. That's going to finish that division. Okay. We got 3 over x minus 2 divided by x plus 5. Okay. And remember, over this step, we have a number one imaginary number. And we must apply cross multiplication. 3 times 1 will be 3. And you know the product between x plus 5 and x minus 2 was x squared plus 3x minus 10. X squared plus 3x minus 10. And this is going to be the solution from the division. Okay, guys, we are out of time. Thank you so much for the attendance. I'm going to take a picture and send it to the WhatsApp group. And let me know if you have doubts or questions. Don't hesitate to let me know. All right. Take care of yourself and have a great and wonderful vacations. See you on Thursday and Tuesday if God wills. Take care of yourself. Bye bye. So long. Take care of yourself.